Hello, my name is Abel, and I welcome you to the third and the last tutorial of the series on how to create 2D animations using the Unity 5 game engine. And, well, in this tutorial, I'm going to focus mostly on scripting using C#, and then I'm going to explain a few concepts which I have missed in the previous tutorials, okay? Like if you look at your game object here and the animator and the animator controller. Okay, and if you get inside the animator panel, I still have to discuss what layers are, and if you look at these transitions, how do you actually create these transitions? What is the has exit time? What are the settings here? And what is the purpose of this graph? Okay, and what exactly is the preview panel here, or this guy here? Okay, and so let's get started right away. And before getting into the details, just want to make sure we understand that in the scripting, what we'll try to do is, in the last tutorial, I shared with you the process of, or the manual process of switching between these states, okay, using the help of these parameters, these variables, and then changing values inside these parameters, okay, which causes a change from one animation state to the other animation state. Now, we will utilize the help of a script, a C# script. And how we do that is, let's come to the project panel inside the assets folder. Let's right click and create a folder, and let's call it scripts. And let's get inside the scripts folder, right click again and create a C# script, and let's call it player manager. Now, this is a coding convention that I like to follow. Anytime I want a script to be attached to a particular game object, and the game object has a tag player. And by the way, I tagged it using the options I get here. Okay, I just have to click here, and then I can select player. Okay, I will discuss tag, layer, and the other details of the Unity game engine in my other tutorial. For now, just remember that you can tag a player, okay, with these tags. This is a player, and so I like to name the scripts using this convention, player manager, okay. Had this been a dog, I could have called it a dog manager, or had this been a tank, I could have called it a tank manager, okay. So anybody else who's looking at this script can intuitively figure it out that, hey, maybe this script is used to manage a player. Okay, so that's the basic idea. And let's double click the script, and now what's going to happen, MonoDevelop is going to open the script for us. MonoDevelop is a programming environment, or in technical terms, an integrated development environment, which provides us with this kind of an interface, okay, for managing, writing the code, and doing stuff like that. So the first thing that I like to do is I like to arrange these brackets like this. And the reason, in my experience, I've found that as the code becomes more and more complex, more and more lines of code are added, this sort of an organization helps reach this code and figure out where stuff is. It makes things a lot more easier. But like I say, this is just a guideline for you. Please feel free to use your own coding conventions. The objective is to write code which can be easily maintained. The objective is to make sure that your code is manageable and is easy to maintain and easy for you to understand and update. Okay, so this is what a C# script in Unity looks like. Okay, now let's have a look here. Right on the top, you have this tab, and every time you open a script in MonoDevelop, it opens up in its own tab. And when you have many scripts here and you open them up, they will open in their separate tabs. And right on the top, you have the name of the script here, because this is a player manager script. So here's the title of the script, player manager, followed by a dot and an extension, okay? And the CS is an abbreviation of C#. So just by looking at the title of a script, you can figure out that it's a C# script or it's a JavaScript. For JavaScript, this would have been JS.js. Okay, so we have a player manager.cs script which has these many lines, lines of code. Okay, if you've heard about the term lines of code, it simply means these lines here. Okay, because on this line you have some code and then you have some code, right? So these are all lines of code. And in programming projects, complex projects, it's not unusual to see these programs spawn across thousands of lines of codes. So if you hear somebody saying my software has thousands and thousands of lines of code, or LOC in abbreviated form, so now you'll understand what they're referring to. They're talking about these lines here. Okay, so let's have a look at the first line. The first line is starting with a keyword called using, which is a way of telling the compiler, because all of these code lines are going to be compiled and interpreted. But I'm not going to get into the technical details. Maybe I reserve it for another tutorial. But for now, you may understand it that the first lines will tell the Unity compiler, okay, the C# compiler, that hey, using Unity engine, I want to use Unity engine. I want to use system.collections, okay? And what are the Unity engine? These are classes. And what are classes? Classes are blueprints in technical terms, but in simple language, I like to call them as toolboxes. They contain functionality, they contain data that you can use, and then use these to group your programs or your scripts and create more functionality, okay? I like to call them toolboxes. So you're essentially telling in the first line that I want to use the Unity engine toolbox, I want to use the system.collections toolbox, and that's how it goes. You can have more using statements, okay? Then here, this is a blank line, so don't worry about it. It's just for formatting your code, for improving the readability of your code, okay? To the compiler, it doesn't make a difference. It's going to ignore it. The fourth line of code starts with public, class, and the name of the class. Then you have a colon and mono behavior, okay? This is another class, okay? Now, here's an important object-oriented programming concept called inheritance. Inheritance is when this class wants to get all the information or get all the methods or get all the stuff inside this class. Okay, this class. Player manager says, hey, computer, what I want to do is I want access to everything that's inside mono behavior. And how can I do that? All right, using the colon. It's very simple. Anything that's on the right-hand side of a colon becomes the superclass in technical terms. Means this class says, okay, I'm going to place a colon here and I'm going to name a class here. And then just by doing that, everything in this class will come to me. This is inheritance, okay? Just like in real life, this is the parent and the parent says, okay, this is my child. And just because there is a inheritance relationship using the colon, I give everything to my child, okay? This is the child class, this is the parent class, all right? So remember, anything that's on the left-hand side of this colon is the child class. Anything on the right-hand side of this colon is the parent class or the super class. So maybe in another tutorial, I'm going to discuss things in detail. For now, just remember that there's some inheritance going on here. And with inheritance, what happens is everything here in this class will be given to this class. And what do you have in this class? All right, in classes, you can have something called methods. These are methods, okay? Methods are blocks of code where something happens. It provides a sort of functionality. So you have the start method, you have the update method, which are actually inside the mono behavior. And because you're doing some inheritance, okay, so mono behavior is going to give everything to the player manager. And that's why inside the class called player manager, you're able to use these methods, okay? These are two very important methods, and that's why we're going to have a look at it. And this public, it's a label, which we can give to a particular class. And by virtue of using this public, player manager becomes available to all the people inside the scripts folder and essentially inside your application. All right, so remember, if you put a label public to a class, it's going to be available to the rest of the script and to the rest of the application without any restriction, okay? Unless you impose it, which is which happens in advanced concepts or advanced programming techniques. But for now, we'll be using just a public keyword. So that's it. So once you start your class in this manner, you open a bracket and you close a bracket, and in between these two brackets, you write all the code which you want to do. Okay, so here. Now, what is this line here? Let me show you. When you write 2 forward slashes and then you write anything after that, that becomes a comment. In scripting or in programming, the concept of comments is very important, because just think of it. If you write one program today and then you write another program tomorrow, and then you make writing programs your career, or you're really passionate about writing programs and you write a lot of programs. So imagine that you write this program today and then you come back to it after a year. Do you really think that you're going to understand everything that's written here? Because you've been working on so many projects, so many complex programs, it becomes a little difficult, right? And that's when the comments come into action. If you've written something here, it would be like a reminder for you. You know, these are clues as to what's going to happen in the next chunk of code. So these are very important. So I really encourage you to use comments, because it's going to make life very easy for you. And also, once you start working in teams, this will be a very essential way of writing code, commenting the code. So Unity development team has given us information that this method can be used for initialization. Now, what do you mean by initialization? So I'm going to use an example of a football team. Okay, when a football team wants to go out and play a game, what do they do? First of all, they put on their boots, they do a team meeting, and they decide the strategy. Everybody gets pumped up, they do some motivational talks, they sit down, somebody's doing deep breathing, somebody's doing jogging on the spot. They're kind of preparing themselves, right? And that's initialization. Before the main activity happens, the act of doing small things so that you're able to perform the main activity is initialization. You know, getting ready for the main event. So anything that you want to accomplish would need some sort of an initialization, okay? And all the initialization code would come here inside the start method, okay? And what is this void? This void is technically called a return type. In programming, a method can have a return type, okay? What's a return type? Okay, so why do you have a method in the first place? When you use a method, you want something to be done, right? And sometimes, for an example, you're using a method to calculate the sum of two numbers. So you just want to say, hey, I got two numbers. And what I want is, I want you to add these two numbers and give me back the sum, all right? So this give me back requires the method to return something to you, okay? And this return means that you would also need to tell the method what can be returned. So this return type essentially indicates the type of the data you're getting back. Okay, in this case, void means this method start is not going to return anything. So that's why we use a keyword void. But in programming, you can use int for integer, means the method is going to return an integer data type for you. Okay, but that's specific to programming and maybe well covered in some other tutorial. For now, my objective is to show you how you can automate the process of switching between these animation states. Okay, so now let's introduce you to the first secret here. And the first secret is, okay, first let me just remove the component here. I probably had added it. And okay, so the first secret is, since you've created your player manager script, right? You also need to understand that this player manager, a script, is nothing but a component. Now what's a component? These are all components. These are attached to a game object. So let's go ahead and show you how you can add a component. You can add it by dragging and dropping a script here, and it gets added to the list of components in the inspector panel. This is the first way. This is the first way. And you can delete a component by clicking the gear icon and selecting remove component. The second way of adding a component is via the add component button. You need to you need to drill down to the scripts, because in this case it's a scripts component, and then select player manager, and this adds the player manager script to the list of components here. Now the secret here is you need to understand that once you add a script here, you can do some coding and access the rest of the components. That's the first step, a very important step once you start your journey into Unity programming, Unity scripting. The first step is to understanding that once you add a script here, this script is going to have the ability to access the rest of the components and change them in some manner. That's the crux. That's the main point of Unity scripting. A script accesses these components, okay? And I'll show you how to do that. So a script accesses these components and then changes the values, changes these properties, and that's how you provide functionality inside a video game, okay? So how can the script access these components? All right, that's the missing, okay, that's another important step. So let's have a look how we can do that, okay? Before I show you how to access these components, you need to understand these components have their titles, okay? Transform, sprite renderer, animator, and these titles are going to be used to provide a way of accessing these components. Let's see. So what you do is just below this bracket here, okay? You write the name of the title. Say, for example, you want to access the animator component, okay? So what is the title here? It's the animator. So you're going to write animator, and it's a good thing that you have the autocomplete. It's a sort of IntelliSense that's inbuilt and mono-developed, so you really don't have to remember everything. You write ANI, and then you can drill down and see which guy you want. So in this case, we want the animator, so you can select the animator. Okay, now you want an animator. Okay, and what you're essentially doing is you're declaring a variable. Okay, so let me just name the variable. This is the name of the variable, and if you remember, a variable is like a box in the computer's memory, which is capable of storing data of a certain type. And in this case, whatever you list before a variable becomes the type of the variable. This variable can take data of type animator, or in simple terms, this variable is going to store the address of any animator component that you're going to give it. All right. So I also introduce you to the technical terminology here. When you say that I'm going to store information about a certain component, we call that we're going to get reference to a certain component and store the reference in a variable. How you do that? We're going to use the start method. Remember, it's used for initialization. Before you can work on the animator, you need to get access to it, right? How we get access is we write anim equals, and we tell the computer, hey, get component. I want a component. Get component. Get component. Okay. Then we open a bracket like this, and we say, which component do we want? So what's the title? It's the animator. So okay, let's write the title. It's animator. Animator. There we go. We close the bracket, and we close the brackets like this. This line of code here is the secret sauce of getting access to the component we want to work with. Okay. First, we declared a variable. We opened a box in the computer's memory, and we labeled it animator, essentially telling us that this location here can take a reference or can store information about an animator component. And then here inside the start method, we wrote anim, or the name of the variable, equals get component. Means you're issuing a command, get component, and you're telling that, hey, I want a component called animator. And using all of this, using the equal sign, we have assigned a reference inside the anim variable. And that's it. That's the first secret step. So you have access to this animator component now. This player manager script has gained access to this animator component. And now, once you have gained access to it, if you notice, if you write anim and you write a period or a dot, you see that you have these couple of methods available now. So you can do a lot of things. If you notice, you have the avatar here and this avatar appears here. Okay, so you can actually access these properties now using the dot notation and change them in whatever manner you want. So that's the whole process of Unity scripting. You access these components and then you make changes to these properties, and that's about it. That's the basics of scripting. So great. Now once we have access to this animator component, the reason we wanted to access this is because this guy here has access to the controller, this cat controller. Okay, and what is this cat controller? When you double click this, the animator panel opens. This is the visual representation of that cat controller. And this cat controller has got these boxes, and we're interested in changing these boxes, okay? Changing the default animation states when something happens in the game. Maybe when you press a certain key on the keyboard, you want the cat to start walking. When you press another key, you want the cat to start running. So yeah, that's what we're going to do now. Okay, and for just this tutorial, we're going to use the keyboard, okay? Because I'm sure you might want to use the mobile, but for mobile, I need to introduce you to the mobile, the Unity 4.6 GUI system, okay, which is introduced in 4.6, and you have a lot more improvements in Unity 5. So maybe I'll do another tutorial on how to get your GUI set up, and then I can show you. It's very easy from there on. It's very easy how you can use mobile input controls, okay? So let's look at the keyboard thing for now. Now, in the update function or method, we have a comment which says update is called one time or once per frame. Now, what's a frame? A frame is a screen refresh, okay? When you look at your computer right now, or if you're looking at your tablet or your phone or a mobile device, what's happening right now is your screen is refreshing at a rapid pace. It's doing it so fast. So the reason why it's refreshing is with every refresh, the controller inside your hardware, there's a microcontroller. It's trying to figure out if some change has taken place between two refreshes. And if there's a change, it's going to, do the appropriate thing. For example, if you have pressed a button, with every refresh, your controller is checking that. Have you pressed a button? Has something happened? Is the battery down? Is the network connectivity lost? Okay, so that's a refresh. So in video game programming, the concept of frame is that in one screen refresh, is there anything happening? Is there anything that needs our attention? So in scripting, Unity scripting in C#, the update method is used to provide all the functionality between every frame, okay? And this frame is actually dependent on your hardware, okay? So here in the update method, you want to put code which will check that whether the user has pressed a particular key or not. And how you do that is you use an if statement. If you're telling the computer, hey, if something happens. So if you open the brackets, if, now you're going to use a class called input dot, and this input has a get key, okay, and you give a key code. These keys on your keyboard are represented using key codes, okay? Key code dot, let's say if the guy wants to walk, let's give it W. All right, there we go. There. So you issue this command. If input.getKey is keycode.w. So what do you want to do? You're going to change the state of this animator component to something. And by default, the orange guy is the default animation state, right? Or the default animation. If you want to change the state from idle to walking, there has to be a condition, right? We did this in the last tutorial, and the conditions can be seen from here. The condition is that the state variable or the state parameter should equals 1. So that's what we're going to do now. We're going to see that anytime the player or the user presses the keyboard key W, we're going to change the state anim.set integer. Remember the parameter here, this is an integer parameter, integer variable, right? So that's the reason we're using anim.set integer, okay? And we need to give the name of the state. It is state and the value. So what value do you want? The condition will be if state is equal to 1, this will change to walking. So okay, I want you to set this state to 1, and that's it. That's it. The moment the user presses the key W on the keyboard, you want the animator here. Let's show you the animator. You want this animator, this guy here, okay, which has these conditions. You want the state to change to 1, and the moment that happens, this idle state would change to walking, as you've seen in the previous tutorial. So that's it. That's it. That's the whole concept behind scripting. We can copy this code and paste it here, and suppose you want this guy to run, right? So let's give it the key code R for run, and that's it. And if you remember, the condition where the walking state will change to running state is if state equals 2, right? The moment you change it to 2, walking will change to running. So let's change this to 2, and that's it. That's it. We can verify this right now. We can get back to the Unity editor and hit the play button, and you're going to see that by default the cat is in the idle animation state. Now, since we have a key called W, when we press, I'm pressing the W key right now, and that's about it. This guy has started walking. If I press the R, it starts running. If I press W again, this guy starts walking. However, I have released the W key, but this guy is still walking. Now, why is that so? I can press the R, and this guy starts running again. I can press W, this guy starts walking again. But wait, in video games, isn't it like we just press the key and the guy starts walking? When we release the key, the guy stops walking. How can we do that? Okay, it's very simple. I introduce you to another method here. It's called input.getKey down. All right. So what we want to do is, instead of just get key, we want to check as long as a particular key is being held down. You do this. Okay. But let's copy this. But if a key, get key up. If a particular key has been released, key up means the key has been released. And which key has been released? It's the W key, right? So that's when you want to change the state to 0. Because if you remember, if you change the state to 0, the character will start playing the idle animation. So we can just put a small comment here, handling the walking to idle state change. That's it. So here, this particular block here is going to manage the walking to idle, or if you want to put an idle here, idle to walking to idle state change. All right. So initially the cat is just in the idle state. When you press the W key, it starts walking because of this state change here. The parameter changes to 1, but the moment you release the key, it gets back to its original state. And the same thing can be done here. Maybe I can remove this. I can copy this whole code, and I can paste it here and key down. This time, all we need to do is change the key to R, and when this thing happens, the change is like this. Okay, and that's it. And that's it. So now in this short few moments, I introduced you to cut and copy and pasting. This is also an important part of programming. Instead of typing things over and over again, you can copy a chunk of code and you can change stuff, and that saves you time. So you have covered this idle to run to idle, a run walking. Okay, could be anything. Now we can verify this. We hit Command P, or we run the application, and that's about it. This guy is standing in the idle animation. Now let's press the W, and this guy starts walking. If you notice, now this is the transition that's been activated, okay? And I release it, and this guy comes back. Okay, so when I hit the W key, this guy starts walking, okay? And I release the W key, this guy gets back to the idle state. When I hit the R key, this guy starts running, right? And the animation state running has been activated. I release the R key, and this guy comes back to the idle state. Okay, so essentially this is the basics of scripting and changing the animation states using scripting. This is the code here. I'm going to provide you this code in the description of this tutorial. You can download it and you can have a look at it. And so yeah, I mean, thank you so much for joining me in this tutorial. Now, I'm going to cover a lot more scripting as we start creating games, but these are small chunks which we need to practice and practice them over and over again so we can get comfortable, and then these concepts will be used in creating games, and then you'll be able to tackle them up with confidence. So now the other thing that I wanted to share with you, which I did not cover in the last tutorial, was the concept of the exit time, has exit time. If you notice that if you select a particular transition, the arrow, it's got this property, has exit time, right? And then you have a couple of settings here, and you have this graph, something like this. So what do you is this of any use? Yes, definitely. But for simple games, I like to keep has exit time unchecked. This has exit time is not very useful when you're creating platformers, because when you have this item checked, it's going to look for an exit time, and exit time can be specified here. When these animations are playing, for example, let me just play an animation. This idle animation is playing, and you have the exit time checked, and you want to change the animation state to maybe running. So if I change it to running here, if you have this has exit time, it's going to take this amount of time before the change takes place. And sometimes in responsive games like the endless runner games, where you press the button and you expect the character to jump immediately, you don't want any delay or time lag, you don't want to use has exit time. Okay, this is useful in 3D games where you're going to blend animations. These animations can be blended together. In certain situations, has exit time is useful, but in this tutorial, has exit time is not used. Because once we start making the platformer, the endless runner game, you would notice that this actually becomes an obstacle. So we remove it. But the rest of the properties here, so if you have the has exit time checked, you specify an exit time. And always remember, this is not the time in seconds. This is a normalized time, means it's a percentage. This 0.825 means this is 80%, okay? This animation will exit, or it will transition only if the current transition or the current animation has played up to 80%. And this fixed duration is, again, a normalized time, this transition duration. Okay, and then you have a transition offset, and then you have the interruption source, any source that can interrupt the transition. So we're not going to bother with this right now and have a look at it in another future tutorial. And what you see here, these settings here, is exactly the same as this graphical thing here. Means you have an option. If you'd like to change settings here by manually entering the values, you can use this option. And if you're more of a graphical person, you can change these settings by manipulating these items here, like this, okay? If I turn this guy on and I start to do changes here, you will notice that things are changing here, right? So this is the graphical way of changing this information. But I like to work here because it gives me more precision. But there are certain situations where file testing, you might want to use this. So for now, we can uncheck has exit time. And so yeah, I think we've covered most of the details here. these are conditions, can be added from here. The last item here in this inspector panel is this preview. What is this preview? This is a three-dimensional grid which shows you the animations. For example, this is walking to running transition, right? So when you press this, it'll show you that, hey, what's happening here. So it's going to give you a preview. So let's stop this animation now. So the last thing that's left is the concept of layers. And since layers is a little advanced concept and includes a lot more detail, I'm going to keep it for another tutorial because it might get confusing at this point of time. But just as an overview, layers can be used to group different kind of animation states, or in technical terms, different kind of state machines. Okay, state machines, if you look at this entire configuration, this is one state machine. Okay, a configuration which is helping you manage changes between different animation states is a state machine. Okay, a couple of state machines will help you provide the different sort of animations which you have in mind. Sometimes you might want to play two animations at the same time. Example, a player is jumping and the player is spinning at the same time. So you can have two different layers. You can create these kind of two different animation states in these separate layers, and then you can merge them and combine them, and you can work with them. So that gives you some sort of flexibility to separate your animations. Or you might want to have an upper body animation in a different layer, a lower body animation in a different layer. So those are layers, and I'm going to show you in another tutorial. So for now, in this tutorial, I showed you that we can create scripts, we can access components in these scripts, we can get references using this line of code, and in the update function, we can use this block of code to check for user input using these classes and their methods, this input class and its method. And this is how you do it using scripting. And well, I really welcome your comments and suggestions in the comments section. And I want to thank you for all your support and all the encouragement. And I really appreciate if you can send me more topics that you're interested in viewing the tutorials for, and I'll try my best to help you that I can. And so yeah, I want to end this tutorial now. It's been a long and lengthy tutorial, but my effort was to give you the groundwork that's essential so that you can practice it over and over again, and then later on the games we do, we're not going to get into so much of details, and we will stick to the business logic or the logic of the gameplay. And so I wish you a great learning experience with Unity. It's a pleasure talking to you, and I look forward to working with you in more tutorials.